Everybody hates solving applications or word problems, especially when they have to do with exponential functions and ideas. So here I've got a couple examples that we are going to look at where you can see how to use your exponential functions to solve different types of problems. So the first one says, a sum of 9,000 is invested at an annual interest rate of 8.5% compounded monthly. Find the balance in the account after 3 years. And then the second part says to find the balance after 5 years. So the first thing that we have to do is we need to identify what it is that we're doing. And this word compounded tells you exactly what equation you're going to be using. We're going to use the compound interest formula, which says A of t is equal to P times 1 plus R over N raised to the n t. Okay, so that is the formula we're going to be using. Now the first thing we need to do after identifying our formula is we need to identify our parts. So P is going to be what you put in. So in this case, P is going to be the $9,000. R is your rate. So my rate here was 8.5%. It must always be converted to a decimal, so we would change this to 0.085. And then we have N. So N has to deal with how you're compounded. And here we are compounded monthly. Well, that's an actual number. There are 12 months in a year, so N would be 12. Last we have T, and in this case we want 3 years. Now, when we're using the compound interest formula, T will always be in years. Once you have all your information, all you have to do is plug it in. So, A of 3 is what we are looking for, and we have 9,000 times 1 plus my rate, 0.085, over my N, which was 12, and we're going to raise it to the 12 times 3. Once you do that, all you need to do is plug it into your calculator. So let me go ahead and show you an example of that just so you're familiar. Now obviously this is the TI-36X Pro, so you need to pay attention to the calculator you have, as your steps might not be completely identical to the ones I'm about to show you, but they should be kind of close or the same idea. So here there's a couple ways that you could approach this. First is to do everything individually. So I'm going to show you what that looks like. Doing everything individually says you're going to start inside your parentheses here. So we're going to start with the fraction, 0.085. Oops. And we're going to divide that by 12, and we're going to hit enter. And then we're just simply going to add 1, so hit 1. So notice it says answer. ANS is going to be the number that was housed right above it. And we're going to add 1 to that answer. Then we have to take it to a power. So on my calculator, the power button is right here. It is x to this little square, but yours may look a little bit different. Some of them have, say, x to the y or y to the x. Some calculators use the little caret, okay? So it just depends on what your calculator is doing. For mine, it is this button here, and so notice I'm taking my answer up to a power. I'm going to open a parentheses, and I'm going to do 12 times 3 inside it, and hit enter. And then I have to multiply that number by 9,000. Okay, so there we go. We've got $11,603.72. So that's the long way, doing it step by step. If you are, say, brave or think that you can follow what you're doing to enter it all in at once, to do that would look like this. You would type 9,000, open a parentheses. You're going to do 1 plus, open another one. 0.085 divided by 12. You have to close it, you have to close it, and you're going to raise it to the 12 times 3. Now, if I entered everything in correctly, I should get the same answer we just got, and I do. So whether you are entering it all in at once or doing it step by step does not matter. You should get the same answer either way. But always be sure to check your work. In other words, if you're going to enter it all in at once, make sure you enter it all in more than once. Verify that your answers are coming out the same, which will alleviate any potential calculator errors that you may have. So here, this is going to then be that A of 3 is $11,603, and then we always round it to the nearest cent, so 72 cents. Now we already did all of this for this second part. The only difference is here my t is going to be 5. Everything else is going to stay the same. So in this case we're looking at t of 5, and it's still going to be the 9,000. 1 plus my rate is still 8.5%. We're still compounding monthly, only this time it's for 5 years. Okay, so again, doing that same thing, you could do it step by step or you could do it all at once. And so this would be 9,000 times 1 plus, open another parenthesis, 0.085 divided by 12, close them, and raise it to the 12 times 5. And here we end up getting A of 5 is going to be $13,745.71. Alright, let's take a look at another problem. So here this one says a total of $12,000 is invested at an annual rate of 9%. Find the balance after 5 years if compounded quarterly, and then if compounded continuously. Okay, so first things first, we've got this compounded quarterly, so we are going to be using that A of t equals P times 1 plus R over N raised to the NT. However, down here we've got compounded continuously, so this is called the PERT equation. This one is going to use A equals P e to the RT. Okay, so two different equations, but most of the information used is going to be very similar. So here we've got that the money we're putting in is $12,000. My rate here is going to be 9%. Again, convert to a decimal, 0.09. And then in this case, my N is going to be quarterly, which if you think of how many quarters are in a dollar, that would be 4. And then we have your T, which is 5 years. So let's go ahead and plug our information in. So here we're going to have A of 5 is going to be 12,000 times 1 plus 0.09 divided by 4 raised to the 4 times 5. So again, you'll plug all of that into your calculator, and in this case you're going to get that A of 5 is going to be $18,726.11. Now, compounding continuously is going to be slightly different. Here, my P is still going to be the $12,000. My rate is still 9%. My T is going to be 5. But here we don't have the N value. Okay, so here what we have is we have that A of 5 is going to be $12,000 E raised to the 0.09 times 5. So for that one, when we're plugging them into our calculator. And again, remember, mine might be slightly different than your calculator. Here we're going to do 12,000, but then we need to use E. So if you notice, I have this button right here that has E to the box. So yours may say E to the X or E to the Y, and so we're going to use that button. So notice I have this E that shows up in my calculator, and then we're going to go 0.09 times 5 and hit enter. And so that's going to spit out our answer. And so what we have here is we have that A of 5 is equal to $18,819.75. Alright, let's look at something that is slightly different in characteristics. So here we have, let Y represent the mass of a quantity of radioactive element whose half-life is 25 years. After T years, the mass in grams is given by the following equation. What is the initial mass when T equals 0? So in this case, when T equals 0, what it means is that we have the equation Y is equal to 10 times 1/2 raised to the 0 over 25. So again, you would plug this into your calculator the same way we were just doing, and what we're going to end up with is we are going to end up with Y equaling 10 grams. Now the second part wants to know how much after it's 80. And so here we would have that Y is equal to 10 times 1/2 raised to the 80 over 25. Again, use your calculator to do the work that you need to do, and what you're going to come out with is that Y is equal to 1.088 grams. Alright, this next one says the approximate number of fruit flies in an exponential population after T hours is given by the following equation. What is the initial number of fruit flies in the population? So initial is asking for T equaling 0. So here we're going to look at Q of 0 is going to be 20 e to the 0.003 times 0. So in this case, Q of 0 is going to come out to be 20 fruit flies. The second part wants to know how large it is after 72 years. So in this case, we're looking at T being 72. So here we would have Q of 72 is equal to 20 e to the 0.003 times 72. So my Q of 72 is going to come out to be 24.822 fruit flies. So I hope those help with being able to look at applications and apply exponential functions to help you solve them. If you have any questions, please let me know. Otherwise, be creative, and I will see you next time.